Hi, boys and girls, and welcome to the very last lesson in Unit 10, Converting Units of Measure. Our goal is to convert measurement units to solve multi-step problems that involve time. So we're adding another layer to our conversions. We're adding time conversions. Now, the practices we need to demonstrate are making sense of problems. You see, we already have thinking about what makes sense on the board because that's going to be extremely important, or on the screen, I should say. We need to attend to precision, make use of structure, model with mathematics, construct good argument. Okay, practice with elapsed time because as we saw here on the learning scale, these are two skills that we need to already have. We must be able to convert measurement units and we need to be able to calculate elapsed time. You might remember the T-chart strategy. Zaya arrived at the 5th grade dance at 5:45. We're assuming that's p.m. because dances do not take place during the morning. No one goes to a dance at 5:45 a.m. So at 5:45 p.m. and she stayed for 1 hour and 14 minutes. So here we're going to say, okay, 1 hour. Let's do that on the other side. 1 hour would be 6:45 p.m. And then we're going to add 10 minutes, which would be 6:55 p.m. And then we're going to add the 4th minute for 14 minutes, and that would be 6:59 p.m. So what time did Zaya leave? She left at 6:59 p.m. Do you see how that works? 1 hour and 14 minutes. So we use the T-chart this way for the first one. Now let's erase our T-chart and record for the second problem. And I'll likely do this one in smaller writing. Shushi arrived 2 hours late at 7:30. Oh, so this is the same dance. What time did the dance begin? Oh boy. So now we have a starting time that we're starting with of 7:30, but we're counting back to figure out when the dance began. So now we have to subtract 2 hours. And what is 7:30 minus 2 hours? It is 5:30. So the dance began at 5:30 p.m. Notice here we were adding 1 hour, and then we added 10 minutes, and then we added 4 minutes. But this time we had to subtract because we want to know what time the dance began. And finally, here at the bottom, this is where we are. Volunteers arrived at 4 and stayed until 7:30. How many minutes were they at the dance? This is where we start converting. First, let's calculate how many hours they were at the dance. So they got there at 4 and they stayed until 7. How are we going to count that? Well, 1 hour would be 6 o'clock. 1 more hour, we're not going to put a 2 there. 1 more hour would be 7 o'clock. And then we don't have an hour here, we have 30 minutes. And that would make it 7:30. So we'll put 30 minutes here. So how many minutes were they at the dance? Well, we're not sure yet, but we do know that they were there for 2 hours, because we add this up, and 30 minutes. Now I will tell you that 1 hour, that's the abbreviation, equals 60 minutes. You've seen this on your reference sheet. So how do we figure out how do we convert hours to minutes here? Exactly. Since we're going from a larger unit to a smaller unit, we're going to multiply. 2 times 60, which is 120. Don't forget, we have to add this 30 minutes. So it's 150 minutes. How long or how many minutes were they at the dance? 150 minutes. Let's keep going. Because remember, our learning goal is to convert measurement units to solve multi-step problems that involve time. So what we did here is we just learned how to calculate elapsed time in case we've forgotten from previous years. But this is not where it ends, boys and girls. We need to be able to do this with multi-step problem solving. So we'll start out small. Grandpa Bob rides his bicycle. Oh, Grandpa Bob is back. He actually rides 6 miles per hour. That's important. So he rides 6 miles. Notice how I'm taking notes. This is a strategy. Per hour. Whenever you see per hour or per minute, that means 1. So per hour. It has no S and no other number, so that means 1 hour. How many miles will he ride in 20 minutes? So he rides 6 miles per hour, but we want to know how many miles, this is the abbreviation, he will ride in 20 minutes. Well, what do I need to do? Well, first, I need to convert this hour to minutes so that I can understand what I need to do after that. So 6 miles is how far he goes in 60 minutes, because we know here 1 hour is 60 minutes. So 1 hour is 60 minutes. So that means he can go 6 miles in 60 minutes. So the question is, how many miles can he go in 20 minutes? Well, we want to know how many miles he can go in 20 of the 60 minutes. So that's going to give us a fraction. 20 of the 60 minutes is 1/3. So we want to know 1/3 of the minutes. We also want to know 1/3 of the miles. So we'll multiply 6 miles times 1/3. And what is 1/3 of 6? If you need to multiply, that's fine. So let's use the strategy. 6 over 1 is the same thing as 6 times 1/3. And we'll multiply the numerator and the denominator. And we have 6/3, which is the same thing as 6 divided by 3, which is 2. But what does that 2 represent? It represents the number of miles. So he will go 2 miles in 20 minutes. Rewind and watch again if you need to. Okay, Ms. Walker arrived at the Kennedy Space Center at 9:30 a.m. That's important. She went on her first tour at 12:15 p.m. after, that's extremely important, after eating lunch for 1/3 of an hour. What time did Ms. Walker eat lunch? That's part 1. And how long did Ms. Walker enjoy the park after eating lunch? That is part 2. I'm going to pause the video so that we don't run out of time. Pause it, see if you can, oh, this is the I do, so I will do this one with you. So she arrived at 9:30, and she went on her first tour at 12:15, so that's somewhere down here. But then she ate lunch for 1/3 of an hour. 1/3 of an hour. Well, 1/3 of an hour. If an hour is 60 minutes, let's figure out how many minutes that is so that we can count backwards. 1/3 times 60 is the same as 60 over 3, which is 60 divided by 3, which is 20. Oh, so 1/3 of an hour is 20 minutes. Ms. Walker had a very short lunch. So I'm going to count 20 minutes. So I'm going to erase my chart, and I'm going to start at 12:15 and count backwards 20 minutes. Why? Because she went on the tour after she ate lunch. So for me to figure out what time she went to lunch, I have to count backwards. So 12:15 minus 20 minutes. If I count back, that would be 11:55. So what time did Miss Walker eat lunch? She ate lunch at 11:55. And then how long did she spend at the park before eating lunch? So now we have to count from 9:30 to 11:55. So let's do 1 hour. That's 10:30. Another hour. That's 11:30. And how do we do 55 minutes? Well, let's add 20 minutes. That would be 11:50. And then let's add 5 more minutes. That would be 11:55. But how long was she at the park before eating lunch? 2 hours and 25 minutes. So question number 1. What time did Miss Walker eat lunch? She ate lunch at 11:55 a.m. How long did Miss Walker enjoy the park before eating lunch? 2 hours and 25 minutes. Now for the we do. This boy ran 100 decameters per hour. How many meters did he run if he ran for a sixth of the day? Pause the video and try this one. Lastly, read these 2 problems and try them on your own. And since we're running out of time, I will come back with the answers to both of these slides, and you can pause the video to see what the answers are and compare them to your work. Okay, so take a look at the answers, and you'll see the process that was followed here. First, we created our equation with the information from the problem. Then we said, okay, I have 100 decameters, and I need to make that into meters, so it's 100 times 10, which is 1,000. So we know that 1,000 meters equals, 1 hour. Okay, then we had to switch, I switched colors. 1 day is 24 hours, so 1/6 of a day, which is the same as 1/6 of 24 hours, is only 4 hours. And so we know that if he had 4 hours, we need to multiply. I hope I'm not going too fast. If so, pause the video. Multiply 4 hours by 1,000 meters, because he goes 1,000 meters in 1 hour. So how many will he go in 4 hours? 4,000 meters. And we moved down a step here because we needed to increase or decrease. We were changing from decameters to meters, so we went down by 10. Before we run out of time, take a look at the very last page. Pause it. to